All right, everybody, welcome back. Today we are going to take a look at building an MCP server using Spring AI. We're still in a lot of change in the world of building MCP servers and AI in general, but Spring did release a 1.0 finally, and now they're on the 1.10 milestone for their Spring AI libraries, which is still in a snapshot, so expect this to change, but we are going to go over how we can come into this model context protocol and take a look at, we'll probably use the weather one since it has 5 different ways that we can use or build MCP servers for our AI tooling. We're not going to go through all of these individually. I'll talk about them generally and then kind of the benefits to which style you should use, and then I'll also show you them in action using VS Code as my tooling to call the weather service here. So you'll see really 3 different styles of MCP servers that you can build. Your first one is going to be WebFlux, then you'll have standard IO, and then you'll have WebMVC. So these are all different ways to interact with the MCP server from whatever your client is going to be. Standard IO is the kind of the default that's been there the longest. Not that any of this is ultra aged at this point, but effectively standard IO will open up a thread between your service or your server and the client and always have that maintained. So with standard IO, your client, if you're using Cloud Desktop or VS Code, it is actually in charge of starting up that MCP server. You won't be using any Spring Boot Gradle commands or Maven commands to run that service. You're actually going to build the jar and then you will pass the jar to your service or to your client, and then your client will be able to run it for you. The other two are WebMVC and WebFlux. WebMVC is going to be more the traditional style of calling something on the web, right? It's going to be completely synchronous, where you're going to make a call, you're going to wait for a response. Generally okay, unless you have that much volume, that's a problem. And then lastly is WebFlux, so that's going to be the reactive Java style of interacting with your MCP service. All right, so we're actually just going to take a look at the WebFlux one probably here. You'll see that the WebFlux server and the WebMVC server are going to act very similarly from just a single user testing it locally standpoint. The source code is going to be really simple in here. You'll see that they have this application properties. The biggest thing in here is if you're using standard IO, this is required to be off. But that's effectively it. All right, in here you're going to have your weather service and then your main application. So I'll start with the we'll start from the outside in, right? So your weather service in here, it's a Spring Boot application, right? So it's all of the annotations that you are already used to, nothing new in here. You'll see that we have this tool callback provider configured here that is going to take in our weather service. So this is all annotation based. It's fantastic. Here there's also this toUpperCase function here. All right, and now coming into the weather service. All right, in here, right, nothing new. We set this up as a service class here. You'll see that we call this API. Nothing new here with REST client. The real capabilities of wiring this up fall with this @tool annotation that comes from the Spring Framework AI library. All right, so in the tool, you effectively give it a description. This is actually important. This description is what your LLM is going to use to be able to semantically understand what that service is doing. So if you were just hooking up a bunch of APIs here, maybe it wouldn't be that important because APIs are effectively your CRUD operations. But here, because we have a method that is get weather forecast by location. That name is fairly descriptive, but then your LLM will be able to actually process what this tooling is doing here. So this is really the power of MCP, right? It's this tool annotation that drives how any LLM that accepts MCP can interact with your code. And it opens up just a lot of capabilities that you'll see as we continue through this journey. One thing to call out here, right? We talked about standard I/O, Webflux, and WebMVC. So for Webflux and WebMVC, it's actually using SSE right now, which is your server-side events, to be able to communicate with your LLM. The new standard is actually streamable HTTP. That is not yet released in the Spring AI framework. There is a PR open for it. Hopefully we'll see it soon. Right, the tool annotation here, right? The rest of this, you write it just like you would write any other Java method in here. You'll see that there's a second tool in here, which is get weather alerts for a US state. Input is 2-letter US state code. So what's interesting is this takes in a 2-letter code, and this one takes in a latitude and longitude here. So it's going to be up to your LLM to understand that, hey, I need to pass this a latitude and a longitude. So it's going to have to find a way to get the latitude and longitude of whatever area you give it, right? Whether it's a state, a zip code, etc. So that is all pretty simple. We can go ahead and run this weather service. All right, very good. So we can see in here that our MCP service started. It says, hey, you have 3 tools available. So that's that latitude and longitude. Weather, that is the forecast by the 2-letter state, and then that is the 2 uppercase that they put in the example. We'll see here it's running on port 8080. So before I show you this running in or against an LLM, let me show you how you can use the MCP Inspector tool to actually see what the heck is going on here. Yeah, model, context, protocol. All right, cool. So we'll see here that it's running on our local server at 6277. So here we are, right? There's nothing going on right now. We'll see that our transport type, right? Like I said, not streamable HTTP yet. We are going to use SSE here, and then it's going to be looking for the port. We're running it on port 8080. The extension here is /SSE. Authentication, we don't have any, and we can just hit connect. And you'll see connected. You can have prompts, you can have tools, which is what we have here, right? Our 3 tools. And you see here that you can actually even test it, right? So if I put in Texas, run tool, great, right? We got a success here, really good. 2 uppercase, let's just do lowercase tx. And ta-da. So this just shows you that it's working. It's an easy way to test it, but we want our LLM to actually be able to call this, right? So let's go to Visual Studio. In here, if you go into the MCP palette, right? So this was Command-Shift-P. And then if you start typing MCP, mine's just in my recent one. List servers, you'll see that I have the standard IO one set up, but I don't have the SSE one set up. So I could just go ahead and hit add server. I don't really like the prompting that it has. So I'm actually just going to go ahead and go to the configuration. So the first thing this needs is a name. So we'll call it the Spring Weather SSE tooling here. And then we'll have to give it a type, which will be SSE. And then a URL, which will be localhost 8080/SSE. You see it'll give us the option to start it here. So we'll go ahead and run that, and you'll see that my 3 tools are exposed now to the application. All right, very good. So now we can go ahead and start chatting with the GitHub Copilot tooling. You have to make sure that you use a model that supports tooling. Claude does, so we'll go ahead and use that. And actually, we have to switch this to agent mode. And then we can go ahead, and if you click this, it will go ahead and refresh the tools that it has available, and we should be good. All right, so you can see here, it's going to run get alerts against our, sorry about that. Let me go and actually comment out the other server. Here we'll see that I've commented out the standard IO version of this. I also switched our model to Claude Sonnet 4. I've had varying degrees of success forcing my GitHub Copilot to call a tool. But now that this is running with SSE, let's go ahead and see what we get here. All right, so if you remember the MCP server in the tool, it was set up to take a latitude and a longitude. So our LLM with the @tool annotation was able to understand that, and it went and fetched the latitude and longitude based off of Claude's model, and then passed that in to our MCP service. Here we can see it's calling the SSE service that we have set up here. And if we go ahead and hit continue, got this little green check mark, that means it ran successfully. And it's now going to go ahead and format the output really nicely. What we can do also is we can expand this tool call. We can see the exact input and we can see the output. So the weather API let us know, hey, it's Juneteenth. This is the temperature. So this is the exact output that we got from that weather API, right? The LLM hasn't made or appended anything to this or made any modifications to it. What it did then is it took that output and then it presented it to us in what it thought was a readable format. Well, hopefully this was helpful to you all to understand just how Spring AI and MCP works, right? We didn't go really in depth into the technical nature of it or how to build it ourselves. You can always start with these repos from Spring AI, clone them, and then make updates to them. But also look forward to a future video where we will set up our own MCP server off of some publicly available APIs maybe. Awesome. Well, have a good one, and hopefully this is helpful. Peace.